The k-nearest neighbors (KNN) algorithm is a simple, easy-to-implement supervised machine learning algorithm that can be used to solve both classification and regression problems. A supervised machine learning algorithm, as opposed to an unsupervised machine learning algorithm, is one that relies on labeled, input data, to learn a function that produces an appropriate output when given new unlabeled data. Imagine a computer as a child, we are its supervisor, for example parent, guardian, or teacher, and we want the child or computer to learn what an apple looks like. We will show the child several different pictures, some of which are apples and the rest could be pictures of anything like grapes, bananas. When we see an apple, we shout apple. When it's not an apple, we shout no, not apple. After doing this several times with the child, we show them a picture and ask, is it an apple? And they will correctly, most of the time, say apple. Or no, not apple. Depending on what the picture is. That is supervised machine learning. Supervised machine learning algorithms are used to solve classification or regression problems. A classification problem has a discrete value as its output. For example, plays and does not plays are discrete. There is no middle ground. The analogy above of teaching a child to identify an apple is another example of a classification problem. A regression problem has a real number, a number with a decimal point, as its output. For example, we could use the data in the table below to estimate someone's weight given their height. Data used in a regression analysis will look similar to the data shown in the image above. We have an independent variable, or set of independent variables, and a dependent variable, the thing we are trying to guess given our independent variables. For instance, we could say height is the independent variable and weight is the dependent variable. Let us take a simple case to understand this algorithm. Following is a spread of black triangles and red squares. You intend to find out the class of the yellow star. Yellow star can either be black triangle or red square and nothing else. The KNN algorithm is the nearest neighbor we wish to take the vote from. Let's say k equals 3. Hence, we will now make a circle with yellow star as the center just as big as 2 and close, only 3 data points on the plane. The 3 closest points to yellow star is all black triangle. Hence, with a good confidence level, we can say that the yellow star should belong to the class black triangle. Here, the choice became very obvious as all 3 votes from the closest neighbor went to black triangle. The choice of the parameter k is very crucial in this algorithm. Next, we will understand what are the factors to be considered to conclude the best k. First, let us try to understand what exactly does k influence in the algorithm. If we see the last example, given that all the 6 training observation remain constant, with a given k value we can make boundaries of each class. These boundaries will segregate black triangle from red square. In the same way, let's try to see the effect of value k on the class boundaries. The following are the different boundaries separating the 2 classes with different values of k. If you watch carefully, you can see that the boundary becomes smoother with increasing value of k. With k increasing to infinity it finally becomes all blue, or all red depending on the total majority. The training error rate and the validation error rate are 2 parameters we need to access different k values.
So, this is all about KNN. In our dataset, we have to classify whether our reviews are positive or negative. So, we will use KNN algorithm. Here is the code, implementation of KNN. Firstly, we will find out the optimal value of k. We will find optimal value of k using cross-validation. Cross-validation is a technique which helps in finding out the best estimator for any algorithm. I have provided you the link where you can go through the details of cross-validation. Using cross-validation, we get our optimal k value equals to 5. Also from the graph, we can see that the error rate is minimum at k equals to 5. Now, we fit our training data to KNN algorithm with the optimal value of k. After that we will test our model using test data, with 2 performance metrics. First is confusion matrix. A confusion matrix is a table that is often used to describe the performance of a classification model, or classifier, on a set of test data, for which the true values are known. It allows the visualization of the performance of an algorithm. I have also provided the link for confusion matrix to learn more. Our next metric is accuracy, in which we simply calculate the error between train and test and take out the accuracy. The accuracy we get is 62.4%, which is not so good, because we have largely sampled the data. Also, there are many other encoding techniques like word-to-vector, TF-IDF, and other algorithms, with which the accuracy can be improved. I will suggest you all to go on ahead, and apply other encoding techniques and algorithms, and let us see who among us get the highest accuracy. This is all for this project. Of course, I have not gone into much detail, because of lesser time duration. But of course in future we will organize a boot camp. We will dive deep into machine learning. The basic idea of doing these projects is to give you all the understanding of machine learning projects and how to work on real-world dataset. Hope you like these video. See you all in the next project. Don't forget to like, share and subscribe the channel. Code link is given in the description.